So, here overall force on Q naught is given by sum of the individual forces, that is F1 0 and F2 0. So, what are the common things I have taken here? 1 by 4 pi epsilon Q naught is common, and remaining things we have to write here. Okay. And for that we can take here sigma, where for example n is changing from 1 to 2, 1 by what is there here, r n 0 magnitude cube, and here r 10 bar. So, like this we can able to write. Okay. So, this is the superposition principle of the Coulombs law. Now, based on that we will see one problem. Find the force on a 100 microcoulomb charge which is available at 003, 100 microcoulomb 003. So, this is our observation point, because at this point only we are finding the force. So, observation point is equal to 003, and on which charge we have to calculate? Test charge is equal to 100 microcoulomb, okay, and that is available at 003. If 4 like charges of 20 microcoulomb are located on the x and y axis at plus or minus 4 meters. So, here due to 4 charges we have to calculate the force on the fifth charge, that is 100 microcoulomb, which is available at 003. 003 means that is on the z axis. So, here you have 100 microcoulomb charge, and this is the x axis, negative x axis, this is the y axis, this is the negative y axis. And since they have given plus or minus 4, on positive x axis we have to take this coordinate is 400, on negative x axis that is minus 400, on positive y axis 0, 40, because x coordinate and z coordinate are zeros on the positive y axis or y axis, and the negative y axis is nothing but 0, minus 40, like this the coordinates are available. So, due to all these 4 charges, what is the total force available on the fifth charge at 003? Without doing the calculation, we can able to tell what is the resultant force direction. Okay, how it is possible, that you see. For example, I am taking this entire 3 axis, I will take like this. Here x axis is coming towards you, so you will see a dot like this. This is the y axis, this is z axis. So, point or the test charge is available at 003, and one charge is available at 040, another charge is available at 0 minus 40. I am not talking about now x axis. On the x axis also at 400 and minus 400, 2 charges are available. Those are available like this only. On the x axis those are available. Now, for the time being I am not talking about that one. So, now I am talking about the 2 charges available on the y axis. So, if you assume the charge which is available at 040 only, due to that particular charge, what is the force direction means? Like this we have to take. The force direction is along the line which is joining the test charge and the source charge. Now, based upon the charge which is available at 0 minus 40, the force on the test charge is along the line which is joining those two, that is like this. Now, 2 forces directions I have given. Similarly, 2 more forces will be there due to the charges available on the x axis, but I am not representing those 2 here, but effect is same thing. So, one is like this, another one is like this. What is the resultant force direction means? You will be having along the z direction only. Okay. The remaining y components will be cancelled out. The resultant vector direction will be in the z direction. It is like a vector addition rule only. The resultant vector will be like this, you will get. Okay. So, this is one vector, this is another vector. How to add these two? We have to take the parallel vector for one vector, then for these two you can able to apply vector addition rule. starting from the tail of the first vector to the head of the second vector, we have to take the vector addition. So, resultant vector will be along the z direction. Same thing will be applicable for the remaining two charges on the x axis also. For that also we will be having the resultant direction in the z direction only. So, what is the conclusion here? Without starting the calculation of the resultant force, so here only we can able to conclude that the resultant force will be having the direction only in the z direction. It is not having the components in the x direction and y direction. Now, we will solve the problem, same thing we will get. Okay. And we have seen here observation point is at 0, 0, 3, that is on the z axis. Now, 4 source charges are there and all the source charges of 20 microcoulombs only. Okay. So, that one we can take. Here I am taking the numbering 1, this is 2 and this is 3 and this is 4, and our test charge I will take as 5. Okay. So, what we need to calculate now? Total force F15 we have to calculate. For that we need first distance vectors. So, first I will calculate the distance vectors. Okay. So, R15 means 1 is indicating the position 400, 5 is indicating the test charge position, that is 003. What is the formula? Observation minus source. So, it is like this, observation minus source, that is 0 minus 4, that is minus 4, 0 minus 0, that is 0, 3 minus 0, that is 3. What is the magnitude for this one? Magnitude of R15 is square root of 16 plus 9, that is equal to 5 only we will get. Next thing is R25. R25 bar is equal to, based on this charge available at minus 40, we will get the force on 003. That means on the charge 100 microcoulomb available at 003. What is the unit vector? What is the vector here? Vector distance vector, that is 0 minus 4, that is plus 4, 0 minus 0, that is 0, 3 minus 0, that is 3. Like this we will get. What is the magnitude for this one? Magnitude of R25 is equal to again root of 16 plus 9, that is equal to again 5 only. Now, due to third charge, we will get like this. Okay. So, R35 bar is equal to 0 minus 0, that is 0, 0 minus 4 is minus 4, 3 minus 0 is 3. What is the magnitude? You will get again 5 only. Next, finally, R45 bar is equal to, that will be like this. Okay, I did not draw properly here, that is passing through the point 003. So, 0 minus 0 is 0, observation minus source we have to take. So, 0 minus of minus 4 is plus 4, 3 minus 0 is 3. So, again magnitude of R45 will also be 5 only. Now, you have 4 distance vectors. Now, you can able to calculate the total force on the charge, fifth charge, that is a test charge 100 microcoulomb is given by F5 bar is equal to F15 bar plus F25 bar plus F35 bar plus F45 bar. It is equal to, in everything you will be having 1 by 4 pi epsilon, that is 9 into 10 power 9, and in everything you will be having the test charge, that is 100 microcoulomb, that also I am writing here. So, these two I have taken common. Then in F15 you will be having the charge Q1, that is 20 microcoulomb, and second one is also 20 microcoulomb, third one is also 20 microcoulomb only. So, that also we can take common. So, what we will get here? 20 microcoulomb. So, two charges we have taken common, and then you will be having here vectors. But in the denominator all the distance vectors magnitude is 5, 5, 5, 5 only. So, in the denominator we will be having r12 cube. So, that is 5, 5, 5, 5 into 5 into 5. Denominator also we have taken common. Now, the vectors we have to write. So, first one is -4, comma 0, comma 3 plus second vector is 4, 0, 3, third vector is 0, -4, 3 and fourth vector is 0, 4, 3. So, like this we have taken. If you observe one thing, x components if you observe -4 plus 4 will be cancelled, there is no x component. Y components if you observe -4 plus 4 will be cancelled, there is no y component, but only z components are existing. Okay. So, that 3 is coming 4 times, that thing we have to calculate 4 into 3 into a z cap we will write. Okay. So, in this manner we have to do. So, here 5 5 is a 25, 25 4 is a 100, 5 1 is a 5 4 is a 20. So, finally what you are getting here 9 into 4 into 4, that is 9 into 4 into 4 into 10 power 9, 10 power minus 12, that means 10 power minus 3 and 3 came 4 times, that means 4 into 3 into a z cap. So, if you multiply this thing 9 into 4 into 4 into 4 into 3, then you will get 1728 and power minus 3 is there. So, you will be having 1.728 a z cap. I said that the resultant force will be having only a z component, same thing we got here, that is the thing. Okay. Resultant force is having the a z component only, it is not having x components and y components.